Welcome to part 2 of propositional logic. In this part, we're going to focus on translating longer compound statements with multiple logical operators into symbolic form. In order to do this, we should focus on the concept of a well-formed formula, or WFF, also pronounced as woof. A well-formed formula is an arrangement of operator symbols such that the resulting symbolic expressions are grammatically correct. And referring here to the grammatical rules of our symbolic language, our propositional language, or our propositional calculus, as opposed to the natural language like English. This concept of a well-formed formula depends upon the concept of scope. The scope of an operator is the statement or statements that a logical operator connects or operates on. And so basically the reason why it's important to have a kind of grammar or set of rules for constructing well-formed formulas is because we need to clarify the scope of each operator. If you had a whole bunch of capital letters and a whole bunch of logical symbols that didn't have any clear organization, the scope of each of those operators would not be clear. In order to get our rules for well-formed formulas, we're going to express them one by one, and taken together, these rules will remove any ambiguity in the scope of an operator. Rule 1 says that the dot, wedge, horseshoe, and triple bar must go between statements, and any of those operators can go between either a simple statement or a compound statement. So at the top are some examples of well-formed formulas. In the first one, we see the parentheses, P, wedge, Q, and parentheses, horseshoe, tilde, R. And you can see that all of the operators, the wedge and the horseshoe, go between statements, either simple or compound. The wedge goes between two simple statements, P and Q, and the horseshoe goes between two compound statements. On the left is P wedge Q, and on the right is tilde R. We'll talk about the rules for parentheses just in a sec. The second example, P wedge parentheses Q horseshoe tilde R close parentheses, is also a well-formed formula because both the wedge and the horseshoe go between either simple or compound statements. And similarly for number 3, there are 3 wedges, but each one goes between either a simple or a compound statement. But now let's look at the examples that are not well-formed formulas at the bottom. So you'll notice the first example is just the letter P followed by a dot. So this is not a well-formed formula because the P needs to have something coming after it. So an example, if you wanted to make this into a well-formed formula, instead of just P dot, you would need P dot followed by another proposition, whether simple or compound, such as Q. The next example, P, Q, wedge, is not a well-formed formula because the wedge needs to go between two simple or compound propositions. So to rewrite this as a well-formed formula, you could write P, wedge, Q. Now for these problems, you're going to have practice problems on the exercise, and you also have problems on the exams where you need to transform something that's not a well-formed formula to something that is. You will oftentimes have a choice as to exactly how you rewrite it. So for example, with number 4, you get to choose what to put after the dot to make it into a well-formed formula. It could be a simple proposition like A or Q, or it could be a compound proposition. For number 6, we have horseshoe P. This one is missing a simple or compound proposition before the horseshoe. So we could rewrite it as Q horseshoe P to make it into a well-formed formula. The last example, P wedge tilde, is not a well-formed formula because there's no simple or compound proposition happening after the wedge. After the wedge, all you have is the tilde. But the tilde has to be followed by either a simple or compound proposition. It itself is not a simple or compound proposition. So to rewrite this into a well-formed formula, we could make it into P wedge tilde Q. Rule 2 for well-formed formulas is that the tilde goes in front of the statement it negates. So here are some examples of well-formed formulas. Tilde, open parentheses, P, wedge, Q, close parentheses, horseshoe, tilde, R. You'll notice that the first tilde goes before parentheses, P, wedge, Q, and the second tilde goes before the simple proposition, R, but they both go before a statement. In number 2, we have two tildes again, but it's still a well-formed formula. One tilde is outside the second set of parentheses in number 2. The other tilde is inside the parentheses. But they follow the rule. The one outside the parentheses indicates the entire expression, open parentheses, tilde q dot s, close parentheses. The second tilde negates only q, but it still is going in front of the statement it negates, so it's fine. And then look at number 3. This is a well-formed formula. It's perfectly fine to have two or more tildes placed in front of each other. So the tilde that's closest to the P, which you can see here, this negates just the P. But the second one negates the whole expression tilde P. So it still counts as a well-formed formula. Let's look at problems 4 and 5 to see examples of ones that don't follow the rule. So number 4, this is P tilde. In order to make this into a well-formed formula, we have to put the tilde in front of the P, because that's to go in front of the proposition it negates. For number 5, we have a tilde outside the parentheses. So we could either negate the entire compound proposition inside the parentheses. We could write this as tilde open parentheses P wedge Q close parentheses, or we could put the tilde inside the parentheses so that it negates only the P or only the Q. So for example, we could say open parentheses not P wedge Q, or we could say open parentheses P wedge Q and put the tilde in front of the Q, so P wedge tilde Q. Either of those would be well-formed formulas. Rule 3 for well-formed formulas is that the tilde cannot by itself go between statements. In statement 1, P wedge tilde Q, the tilde goes before the Q alone, so it's fine. In example 2, P tilde Q, it's not a well-formed formula because it goes between the P and the Q. So to make it well-formed, we have to introduce another logical operator between the P and the Q, such as a wedge, P wedge tilde Q. Or we could write P horseshoe tilde Q, and it becomes a well-formed formula. Rule 4 is that we use parentheses, brackets, or braces to eliminate ambiguity in the scope of operators. The rule is that the logical operator that's outside of the parentheses is the main operator. You can only use parentheses if you want to. The brackets and braces are optional. Those are to help you keep track of pairs of parentheses. The total number of open parentheses has to match the total number of closed parentheses. And it's important to be able to eliminate, in order to identify rather, the main operator. So for example, in number 1, the main operator is the dot, which you can see outside the parentheses. So I'll circle the dot here. Whichever operator is outside of parentheses is the main operator. Now let's look at the ones that are not well formed. We have two operators, a wedge and a dot outside of parentheses. So in order to rewrite this into a well-formed formula, we need to add one set of parentheses. We can add it around either the wedge or around the dot. So if we add it around the wedge, it becomes open parentheses, wedge Q, close parentheses, dot R. In the second example, we have a dot, a wedge, and another dot that are all outside of parentheses. So we have to add a couple of sets of parentheses to fix this one. So for example, we could do P dot Q in parentheses and put a second set of parentheses around the second dot. Therefore, we only have the wedge outside of parentheses, so it's a well-formed formula. In the third example, we have a wedge outside of parentheses and a dot inside parentheses, but the dot can't go just with one other simple proposition. So to make this well-formed, we could introduce a second, or we could rather move the open parenthesis before the Q, and then it becomes well-formed. Another thing you could do is to put the parentheses around the wedge instead. This is another one that would be well formed. But either way, it's never well formed to have just the .r by itself inside parentheses. So to summarize the rules for well-formed formulas, Rule 1, the dot, wedge, horseshoe, and triple bar must go between statements, either simple or compound. Rule 2, the tilde goes in front of the statement it negates. Rule 3, the tilde cannot by itself go between statements. Rule 4, we use parentheses and, if you wish, brackets or braces to eliminate ambiguity in the scope of operators. So the idea is if you have more than one operator that connects statements, at least one of those operators has to be inside parentheses. The one that is outside parentheses or that is in fewer sets of parentheses has scope over the ones that are inside parentheses or in more sets of parentheses. So let's look at some sample problems. With each of these, we're going to say if it's well-formed or not. If it's not well-formed, we want to rewrite it. Let's look at number 1, R tilde wedge T. This is not a well-formed formula because the tilde has to go before the statement it negates. To make it into a well-formed formula, we could put the tilde in front of the R. Number 2 is K. That is a well-formed formula because there are no logical operators on it. It's just a simple proposition. Number 3, K dot P tilde Q. It's not a well-formed formula because the tilde cannot by itself go between the P and the Q. Therefore, we have to add another operator between the P and the Q. Since it's not specified, we can choose which operator to add. In this case, I've chosen a wedge. 4, tilde P wedge tilde P. It is a well-formed formula. We have a wedge connecting two statements, in this case the compound statements, tilde P and tilde P, and the tildes each go in front of the statement they negate, so there's no problem. Number 5, PQ. This is not a well-formed formula because you cannot have two simple propositions right next to each other with no logical operator to conjoin them. So we have to add a logical operator to make it well-formed. We have a choice. We could choose any of the operators that connect statements. In this case, I chose the horseshoe. Number 6, P wedge Q dot S. Not a well-formed formula because we have two logical operators that connect statements, the wedge and the dot, outside of parentheses. We have to add at least one set of parentheses here to eliminate ambiguity. Number 7, tilde tilde P. This is a well-formed formula. The first tilde negates just the P. The second tilde negates the tilde P. So there's no real problem there. You can have any number of tildes you want in front of either a simple or a compound statement. So the main operator is the one that has the entire well-formed formula in its scope. And there's only one main operator in a compound statement. Let's look at some examples to get practice identifying the main operator. So in number 1, we have only one operator, the tilde. So that is the main operator. We can circle it to remind ourselves. Number 2, tilde open parentheses P wedge Q close parentheses. The main operator is again the tilde. When you have more than one operator, if there is a set of parentheses, the operator outside the parentheses is going to have priority. It will be the main operator. Number 3, tilde P wedge Q. In this case, the tilde only negates the P that is in front of. There's no parentheses here, unlike in number 2. So the main operator is the wedge. The wedge has scope over both the tilde P and the Q. It brings them both together, so they're both within its scope. Therefore, it is the main operator. Number 4. This is a very long expression. I won't read the whole thing. It's not as tricky to find the main operator, though, as you may at first suspect. The main operator is the one outside parentheses, the triple bar. So let's look at some sample problems, do some translations with these longer compound statements. Her jewelry is very valuable, and either she can keep it or sell it for a lot of money. As before, let's start by identifying the logical operator terms and circling them. So that's the and, we're going to translate that with a dot, and we have an either or, which we can translate with the wedge. We could also circle the word either to remind us that it's part of the operator, but It doesn't add another symbol, so it's kind of redundant with the or. I don't see any other operator words, so let's underline the simple statements. Her jewelry is very valuable. We could symbolize this by V. She can keep it. That's another simple statement. So we can symbolize that by the letter K. And then the last simple statement is she can sell it for a lot of money. We could symbolize that by L for lot. So we can start by writing out the simple statements and the logical operators that connect them. V, dot, K, wedge, L. You'll notice there's a problem because we have two operators, the dot and the wedge parentheses. So one of them has to go inside parentheses. And you have to figure out which one is the main operator. So to do that, look at the logic of the statement. Her jewelry is very valuable, and either she can keep it or sell it for a lot of money. In this case, the comma gives us a clue. The comma is separating the first conjunct from the second conjunct. That implies the second conjunct is one idea and has to go together. So you're saying that both it's true that her jewelry is valuable and it's true that either she can keep it or sell it for a lot of money. That means the entire disjunction, the either or, itself has to be a conjunct. And that's why we put it together in parentheses. Another sample problem. She is excellent at both math and public speaking, unless I am very mistaken. So as before, let's begin by circling our logical operator words. We have an and, which is symbolized by the dot, and unless, which is symbolized by the wedge. Now let's identify our simple statements. She is excellent at math, which we can symbolize by M, and public speaking. In this case, the second simple statement is she is excellent at public speaking. That has not been completely stated here. It's abbreviated in the ordinary language English version. We could symbolize the entire second simple statement, she's excellent at public speaking, with P. And then the third simple statement is I am very mistaken, which we could symbolize by V. We might otherwise want to use M to remind ourselves of the word mistaken, but we've already used M for she is excellent at math. Therefore, we can overlook it and just use the V to symbolize, to stand for very. We also could have circled the word both. I didn't do it initially because it's redundant with the and. Just like either or form a pair logically and only express one or operator, both and form a pair and express one and operator. So let's put these all together. We have M, dot, P, wedge, V. And we have to decide the priority. Which one of these goes inside parentheses, which goes outside. You'll notice that the both and forms a pair. So that's a kind of clue. It makes more sense to put the parentheses around M.P. She is excellent at math and public speaking, or I am very mistaken. Either Captain America or Iron Man is a sarcastic superhero, but Spider-Man is for sure. So let's start by circling our logical operator words. We have either or, which is symbolized by one logical operator, the wedge. The second logical operator word is but, which stands for the conjunction, like the word and. Our first simple proposition is Captain America is a sarcastic superhero, symbolized by C, or we could have chosen another letter like A. And then Iron Man is a sarcastic superhero is another simple proposition, which we can symbolize by I for Iron Man. You'll notice that in this case we have two simple statements. Captain America is a sarcastic superhero and Iron Man is a sarcastic superhero. They share the same predicate, is a sarcastic superhero, so that predicate is not repeated in the English natural language version of the statement, but we need to keep it clear for ourselves. Logically speaking, the C stands for that entire statement. Captain America is a sarcastic superhero. Our third simple statement is Spider-Man is for sure, which we could symbolize by S. Now putting this together, we have C, wedge, I, dot, S. And we need to think which is the main operator, the wedge or the dot. The one that's the main operator will go outside the parentheses. You can look for clues in this in the wording. In this case, the entire either or comes before the but. That means that entire expression is the first conjunct. So we have to put it together in parentheses. C wedge I goes in parentheses. So parentheses, C wedge I, close parentheses, dot S. is the correct translation in this case. Not both Marvel and DC films are beloved by fans. So as usual, let's begin by circling the logical operator words. We have not, which represents the negation or tilde, and we have both and. So we're going to symbolize this by the dot. Our first simple proposition is Marvel films are beloved by fans. We can symbolize that by M. And the second simple statement is DC films are beloved by fans. We can symbolize that by the D. So putting this together, we have tilde M dot D. But we're not done. There could be a case where the tilde is only negating the M, but the wording would have been different. In that case, it would have been Marvel films are not beloved by fans and DC films are beloved by fans. But the not both means that the tilde is negating the entire conjunction. So that means we have to put M dot D in parentheses. This expresses the idea that the tilde is negating the fact that both of these are true. So it's saying not both of them are true. One of them could be, but not both. It's not the case that either films with Superman or Batman are as popular as films with Iron Man. The first logical operator is not, or you could say the entire phrase, it's not the case that. Symbolize that by the tilde. Then we have an either or, which you will symbolize by the wedge. I don't see any other logical operator words. So the first simple proposition is films with Superman are as popular as films with Iron Man. Symbolize that by S. The second simple statement is films with Batman are as popular as films with Iron Man. And that's it. There's no other simple statement. The main thing that might be confusing about this example is that we have the two simple statements, both of them are abbreviated. The first one is films with Superman are as popular as films with Iron Man, and we don't have that predicate stated twice. The second statement is films with Batman are as popular as films with Iron Man. The first part of that statement, the subject, films with Batman, that is not stated completely either. So we have to kind of read between the lines to figure out what each of our simple statements is. So putting this all together, we have tilde, S, wedge, B. But we have to figure out the scope of the tilde. As written, this is saying either films with Superman are not as popular as films with Iron Man, or films with Batman are as popular as films with Iron Man. But that's not what our statement is saying. It's saying it's not the case that either are as popular as films with Iron Man. The not either is basically indicating that the tilde is supposed to apply to the entire wedge. So in order to indicate the tilde has scope over the entire wedge, we put the S wedge B in parentheses. So not either or neither nor is going to be written like this, with the tilde outside the parentheses.